Don't move the wall now. Don't lean on the wall.
Hi everyone, am I audible?
Yes, sir.
Good, good. So we did the dimensions and we saw that what are the uses of dimensions. Can anybody tell me what are the uses of dimensions? Front row corner boy. Towards my left. That means you're right. Yeah.
Sir,
Yeah, go on. What's your name?
Ramdev, sir.
Ramdev.
Yes, sir.
Okay. Go on, go on. What are the three uses of dimensions?
To check the consistency of the equation, sir.
Okay, and
To derive an equation, sir.
derive an expressions and one more is there. Why don't you guys revise things? This is very important. You cannot gain the concepts unless and until you revise the things that we have done in class. What is the third one? Isn't it written there?
Sir, we are searching, sir.
Searching. What is there to search? Haven't you written the third point? To convert a physical quantity of one system of unit to another system of unit. See
Yes,
there?
sir. Yes, sir.
Okay. Right. The boy just behind you. Give him the mic. No. You only. Who has held the mic? Yeah.
Sir.
What's your name?
Kaushik, sir.
Kaushik.
Yes.
Right. Okay. So what is the dimensions of force?
MLT minus 2.
MLT minus 2. And what is the dimension of work done? This is not at all good. You're not revising.
MLT ML square T minus.
That is correct. Okay. The leftmost girl, in your terms, it will be the rightmost girl. Give her the mic. Front one, yeah. What is the dimensions of coefficient of viscosity?
Sir,
What is your name?
Lata Yarani, sir.
Lata. What is the dimensions of coefficient of viscosity?
ML minus 1, T minus 1.
ML minus 1, T minus 1. So this is not at all good. You all have not done the revision, right? What I require is just, if you would have just seen the paper copies for 1 hour or so, I think that was enough, but you haven't done that also. Promise me that you'll revise from the next class. Will you do that?
Yes, sir.
Okay. Otherwise, I'll start giving you punishments. Today we'll be seeing conversion of one system of units to another. Today we'll see the conversion. Okay, how we can convert any physical quantity from one system of unit to another. Okay, how do we do that? So basically, what is there? Any quantity, if I ask you, how do you represent that? You represent any quantity as n into u. Okay, you tell me the numerical value. You tell me the numerical value and you tell me the units. For example, if I ask you to measure the length, so how will you measure the length? What will you will be giving me the as the answer? So you'll be saying me, sir, it is 5 meter or 5 centimeter or 10 centimeter or 10 millimeter, whatever it be. So you are giving me two terms. One is the numerical value, another one is the unit. Agree? Put your thumbs up.
Yes, sir.
Okay. So you tell me a numerical value and you tell me the units, right? So that physical quantity should remain constant. For example, if I'm writing 10 meters in one system of unit, so that should be written as 1000 centimeters. But both of the quantity are same or not? Both of the quantity are same or not?
Same, sir.
Right? It should be same in any system of unit. The quantity should be same. So that's why N1 U1 should be equals to N2 U2. N1 U1 should be equals to N2 U2. This is the concept. Okay. So total quantities that you represent with N into U should be same in all of the system of units you go. Otherwise, that value will be different. Got it? If you want to get 10 meter of cloth, you can ask for 10 meter cloth or you can say 1000 centimeter of cloth. Are you getting my point?
Yes, sir.
Okay. Now, how do we do this? So basically, any unit we write it dimensionally. Any unit we write it dimensionally as M1, L1, T1. M1 to the power A, L1 to the power B, T1 to the power C. Okay. And in second system of unit, that numerical value is N2 and the dimensions are M2 to the power A, L2 to the power B, T2 to the power C. Okay. This is the representation that we do in the dimensional quantities. Understood? So I'll give you an example. You don't write anything now. You just look at here. Okay, this is very important. If you understood this, you will get the marks very easily, but it will take time. Now see here. For example, if I have to convert 5 centimeter into dash meters, and I don't know this value. Okay, I don't know this value. I'm starting with very easy example, and then I'll move on to difficult dimensions. So what is the dimension of this centimeter? It is a kind of length. So dimensions will be what? Tell me, anyone? Kaushik, you tell me. What are the dimensions here? Lata? What is the dimension here? See, it's a dimensions of length. So you will be writing 5 into M0 L1 T0. Do you agree with me? Yes or no? Put a thumbs up if you agree with me. Right. Same thing here. This value I don't know. I'll be writing this as N2. I'm writing this as N2. And what is the dimension of meter then? Tell me. What is the dimensions of meters? Again, this is length only. So it will be M0 L1 T0. The dimensions will not change. If the dimensions are changed, so these both will become different quantities and we cannot relate them. Whatever be the dimensions of the first one, same should be the dimensions of the second one. Agree? Yes or no? Put a thumbs up if you agree. See, this is very important and easy also at the same time. That's why you should listen it here carefully. So if I want to write N2, can I write N2 as 5 into M1 by M2 to the power 0, L1 by L2, this is 2, to the power 1, T1 by T2 to the power 0. Agree everyone? Yes or no? Right? Okay. Now what we have to do? We have to solve this. So now I can write the same thing as now I can write the same thing as now I can write the same thing as N2 is equals to
Go back. Please don't go back.
are there more to come? Shall I explain from the starting? Shall I explain from the starting? Are there more to come?
Sir, all came.
Okay. Okay. See here, we were discussing about the conversion of one system of units to another. That was the second use of dimensions. First use of dimensions was to check the consistency, and that we had seen in the previous class, right? So any quantity is represented as numerical value and their units. If I ask you to give the value of any quantity, be it measurement, be it weight, be it mass, whatever it be, so you'll give me a numerical value and the unit. For example, if it is 10 kg, 1 meter, 5 centimeter, 5 liters, whatever it be, you'll give me a numerical value and you'll give me a unit. Okay. But that should be constant if we are talking about any system of unit. For example, if I'm asking for 10 meters, so you can ask for 10 meters or you can ask for 1000 centimeters. Both have the same value. From both the cases, you'll get the same length of cloth if you are asking for it. Understood? So either it should be 10 meters or 1000 centimeters. This should not differ. If it got different, then your value will be different. Then it is not same. Then that is not correct instead. Okay, so 10 meters or 1000 centimeters. See, this is quite easy. We know that 1 meter is 100 centimeters, so we can easily convert it. But what if I ask to convert the SI system of unit of force, that is Newton, 5 newtons into CGS system of unit? So that becomes difficult because only one unit is not there. In 1 Newton, we have kg, meter, per second square. So we have 3 terms there. All of them you have to convert. And that becomes quite tedious task. That's why we use the work of dimensions to solve this. Till here, understood everyone? Yes or no? Everyone, the newcomers also.
Yes, sir.
Right. So any system of unit is represented by numerical value and the units, and that should be constant if you're talking about if other system of units. Okay. For example, in one system of unit is N1 U1, second system of unit it should be N2 U2, but both the value should be same. Either you say 10 meter or 1000 centimeter, value should be same. So we were discussing about to change 5 centimeter into dash meters. We are assuming that we don't know this value, how to change 5 centimeter into how much meter it would be. Okay, so what we did, we wrote 5 centimeter here. We wrote the dimensions of centimeter. Centimeter is a kind of length, so its dimension is M0, L1, T0. Second here, we don't know the numerical value. We wrote it N2. And meter is also kind of length, so its dimensions will be M20, L20, L21, and T20. Then what we did, we took this dimensions as a denominator here. Okay, this dimensions as a denominator there. So it will be M1, L1, T1, and respective powers by M2, L2, T2 with the respective powers. Shall we continue from here? Everybody understood or not? Any doubt, anyone? Even if any one of you have any doubt, you can tell me.
Sir, can you explain the first, sir?
Explain the. I could not hear that. Can you please pardon?
Sir, we need to. What is the last two steps, sir?
This from here.
Yes, sir.
Okay. So what we did, see here, we had 5 centimeter and we wanted to convert it into dash meters. We don't know the numerical value. Okay. So what we did here, 5 this centimeter, what is the dimensions of centimeter? That is M0, L1 and T0. Agree?
Yes, sir.
Agree? Then the second thing, in meter case, what is the dimension? Again, it is a kind of length. So it is M20, L21, T20. Why I have written L2 or M1? Okay, why this segregation is there? That is because they have different values. Here the length has got its unit value 1 centimeter. And here the length has got its unit value 1 meter. So that's why I've written is L1 and L2. That's why I've written it different. Now understood or not?
Yes, sir.
Now what we have to do, we have to take these dimensions from here to this side so that we can get this variable N2. So what I did, I divided M1 with M2, L1 with L2 and T1 with T2 with the respective powers. Now see here, the power of M1 and T1 is 0. So I can write it as M2 is equals to 5 times L1 by L2 to the power 1. Agree, yes or no? Everyone? Good. So what is L1? What is the unit of L1? So unit of L1 is, L1 was in the centimeter unit. So I can write it as 1 centimeter. And unit of L2 is in meters. So I'll write it 1 meter to the power 1. So 5 times, if I want to balance this, I can write 1 meter is 100 centimeters. Power 1. So the centimeter got cancelled. So N2 is nothing but 5 upon 100 to the power 1. So N2 is what? 0.05 meters. Understood?
Yes, sir.
Any doubt?
No, sir.
Please don't talk. Write it down fastly. Write it down quickly. Is there any doubt?
No, sir.
Then what discussion is going on in the boys' side? In the middle, what kind of discussion is going on there? Beside Kaushik, I guess. Is there any problem there?
No, sir.
Okay. Write it fast. Shall I change the slide?
No, sir. No.
Okay, write it fast.
Completed, sir.
Done, everyone? Shall I change the slide? Do it fast.
Sir, 1 minute. Sir.
First, you tell me you understood this concept or not, because I'll be asking questions after this.
Understood, sir.
If you have any doubt, you can ask me out. Otherwise, if I'll ask, I'll poke each and every one of you and then I'll ask the questions.
No problem, sir.
Good. You are liking my teaching methodology, or you want some change here, like giving notes or something else? Any change required?
No, sir.
Okay.
No, completed, sir.
Completed?
Yes, sir.
Right. Okay. Now see there. Now see there. What is force? What is force? What is the unit of force? What is the unit of force? Tell me fast. What is the unit of force? I could not hear that.
Yes, sir.
Newton. N. Can you expand this? Basically, force is what? Force is mass times acceleration, right? And if I write that distinctively, so I can write it as kg meters per second square. Yeah.
Sir, can you write the big figures, sir?
A little bit bigger. Okay. 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 No problem. See, what is force? The unit is Newton. Agree? Agree or not? Please
Yes,
focus
sir.
here. So Newton force, how do we get the force? Force is mass times acceleration. Mass times acceleration. From there you can get the unit kg meter per second square. And all of these terms are in SI unit. All of these terms are in SI unit. That's why when you get Newton, you have to put every term of the mass and acceleration in the SI unit. Understood? But what
Yes, sir.
if I get the mass in grams and I get the acceleration in centimeter per second square? So this is the CGS unit of force. CGS unit of force. Centigram second. Okay. And combinedly, this is called dyne. D-Y-N-E. Dyne. Okay. Understood or not?
Sir, what is mean by dyne, sir?
Dyne, like 1 kg meter per second square is termed as 1 Newton. You know this? Similarly, in a CGS unit, 1 gram centimeter per second square is termed as 1 dyne. Understood?
Okay, sir.
Right? Now we have to convert, we have to find the relationship between like 5, if I'm writing 5 Newton and I have to convert it in terms of dyne. I have to convert in terms of dyne. How will I do that? So first of all, I have to do the same thing, same procedure. Please, everyone focus here. What I'll be doing, step number 1, 5. I'll write the dimensions of force. Dimensions of force is what? M1 to the power 1, L1 to the power 1, T1 to the power minus 2. Agree, everyone?
Yes, sir.
Same thing. The dimensions of dyne should be what? This is N2. I don't know. It should be the same. M2 to the power 1, L2 to the power 1, T2 to the power minus 2. Because even here we are talking about kind of force only. So dimensions will not change. Underline, dimensions will not change. Got it? Just the value will change. Just the value will change. Put a thumbs up if you understood till here or not. Back, boys. Good, good. Right. Now, what we have to do, you have to find this N2. How will we find N2? N2 is 5 times M1 upon M2 to the power 1, L1 upon L2 to the power 1, and then T1 upon T2 to the power minus 2. Agree? In this step, any doubt?
No, sir.
Now what we have to do, we have to write the unit value. So what is the unit value of M1? M1 was in CGS unit. CGS unit, Newton, CGS unit. So that is 1 kg. What is M2? M2 is in CGS, sorry, M1 was SI unit. So that's why 1 kg. M2 is in CGS unit. CGS unit, dyne. That's why it will be written as 1 gram. Now length to the power 1. Length. What is length? Length L1. L1 is in SI unit. SI unit 1 meter. And your L2. L2 is in CGS unit 1 centimeter to the power 1. Now time. Time in SI unit or CGS unit. Both are 1 second. 1 second to the power minus 2. Any doubt till here?
No, sir.
Now what will I do? I'll expand that. N2 is 5 times 1 kg. If I want to cancel this kg and gram, I can write kg as 1000 grams by 1 gram to the power 1 multiplied by 1 meter is 100 centimeter by 1 centimeter to the power 1 multiplied by 1 second by 1 second to the power minus 2. Now from there what you get? Gram, gram cancel, centimeter, centimeter cancels. So you'll get 5 into 1000 to the power 1 into 100 to the power 1. So you get what? 5 into 10 to the power 5 times. So 5 Newton is 5 into 10 to the power 5 times. Understood or not? From there I can write 1 Newton is 10 to the power 5 times. Put a thumbs up if you understood till here or not. Any doubt, even if a single doubt you have, you can ask me out. You don't have to feel anything for it. You just ask me out if you have any doubt. Don't feel like this is something stupid or whatever. Doesn't matter. It should be cleared among your minds. Write it down fastly.
Sir,
Next one you have to do. Yeah, go on.
so the equation on the left hand side of the board is not a bit visible, sir. That units 5 into units you have written out, sir. That one.
Which one?
The 5 into 1 kg by 1 gram, that equation, sir, that last bracket is not a bit visible, sir.
This one.
Yes, sir. Correct.
So 5 into, like I just expanded what is M1. M1 is the mass in SI system of unit. So in SI system unit, what is the unit mass? Unit mass is 1 kg. M2 is the mass in CGS system of unit. So in CGS system of unit, what is the unit mass? It is 1 gram. So 1 kg upon 1 gram to the power, that is the dimensional power. Second, you have L1 by L2. L1 is the SI system of unit. So that is 1 meter, L2, CGS, 1 centimeter, power 1. Then time, SI system of unit 1 second. In CGS also we have 1 second, power minus 2.
Okay, sir. Got it.
Write it down fastly. Next one you have to do yourself. Tell me when it is done and do it fast.
Few minutes, sir. Sir, completed, sir.
Everyone done?
Yes,
Shall I
sir.
change the page? Okay.
Yes, sir.
Now, similarly, we converted the SI system of unit of force into CGS system of unit of force. We have SI system of unit of work done. SI system of unit of work done. What is the unit? Unit is joules, if you know. You know that? You know this? What is the formula for work done? Work done is force into displacement. Agree or not?
Yes, sir.
Right? So from there, you have to expand the unit. What will be the unit? So for force, if you expand that, you'll get kg. So okay, let us expand some more then we'll be get to it. So if you expand this, force is mass times acceleration, and that is to be multiplied by displacement. So if you write the unit now, so it will be kg. For acceleration, it is meter per second square, and for displacement, it is meter. So this will become kg meter square per second square. Okay. Now you have to write the dimensions. Now you have to write the dimensions. Dimensions will be m to the power 1, L to the power 2, T to the power minus 2. Till here, do you agree or not?
Yes, sir.
Right. Now what you have to do, this is the SI unit. This is the SI unit. In SI unit, you call force in joules. In SI unit, you write force in joules. But what if we write the same thing? I can write the same thing in CGS unit. This is SI unit. CGS unit, it will be, instead of kg, I'll be writing gram. Instead of meter, I'll be writing centimeter square. Instead of second, I'll be writing second square. Okay. Now this is called erg. E-R-G, erg. Okay. In SI system of unit, work done is joules. In the CGS system of units, the work done is erg. Okay. So you have to convert what 1 joule will be equals to in terms of erg. 1 joule is how much erg? Do this yourself and do it fast. The boy who or girl who answered this question, I will not ask any question for him in the next class. That will be the rule.
10^7, sir.
I guess you did not do it by dimensions, isn't it? Who answered that? Who answered that?
No, sir. You didn't do it by dimensions, sir.
That is
But
wrong. You should do it with dimensions. If you remember something, that is good, but they should do it with dimensions, because that is what I want you to do.
Sir, then 10 to the power minus 1 is right, sir.
That is correct answer. 10 to the power minus 7 is the correct answer. But I need you to do this with dimensions, the way I did it the previous question, like this.
And that's only now we done, sir. We got the answer.
This one, like this. Okay, then that's good. Everyone try to solve this. Everyone try to do this in your paper. All of you. I want all of you to solve this. Try to solve this. It's very easy. Write the dimensions, divide them, find their unit values, and then the rest you have to do this the multiplication. That's it. Done, everyone? I can see only few hands up.
Yes, sir, done, sir.
Everyone? Okay. Okay. Right. How it is to be done? So what you have to do, you have to write the dimensions. 1 into m1 to the power 1, l1 to the power 2, t1 to the power minus 2. Those who have not done, please listen here. This value I don't know. m2 to the power 1, same dimensions it will be. l2 to the power 2, t2 to the power minus 2. Next, what you have to do, N2 is nothing but M1 upon M2, 1 into to the power 1, L1 upon L2 to the power 2, and then T1 upon T2 to the power -2. Put the values. 1 into M1 is SI system of units, so it is 1 kg. So 1 kg upon 1 gram, power 1. 1 meter upon 1 centimeter, power 2. 1 second upon 1 second, power -2. So it will be 1 into kg. If you write it, sorry, I'll be writing this in next page. Writing this in next page. So it will be kg. If you expand, it will be 1000 grams upon 1 gram. Then power 1. 1 meter is 100 centimeter upon 1 centimeter, power 2. Then second time is 1 second upon 1 second, power -2. Doesn't matter because it is 1 only. So 1 into it is 1000, and from here 100 square, because centimeter is cancelled, so it becomes 1000. So it becomes 10 to the power 7. So 1 joule is 10 to the power 7 earths. Understood everyone? Yes or no? Yes or no?
I have a doubt, sir.
Go on.
How does minus come there, sir, for power?
How to solve minus for powers?
No, sir. How does -7 come to power, sir?
How does -7? Where I wrote -7?
In the last slide, you said the -1 is correct, no, sir. 10 power -1.
No, 1 joule is 10 to the power 7 earths. No, not -7.
Sir, 1
See,
minute,
I
can you go to the last slide, sir?
last slide. Okay. Okay,
Yes,
here
sir.
we have written -7.
Sir,
No,
that's
no, that's wrong. That's wrong. It should be +7. +7. Sorry,
Thank you, sir.
it should be +7. Oh, the girl who did that, please rectify it. It should be +7.
Okay, sir.
Okay. Let me check it once. I think it should be 7 only. Just I'll be checking it once. It should be +7, not -7. The girl who did it, what was her name? Who did this?
Sir?
Rectify this. Rectify.
I
Ah.
said 10 to 7 here, sir.
Oh, you said it was 7 only.
Yes, sir.
Okay, my mistake. Sorry. Then everyone understood?
Yes, sir. Understood, sir.
Okay. See, now we'll study about two things. Did we discuss about accuracy and precision? Accuracy and precision. We have to discuss about accuracy and precision.
Yes,
What is the
sir.
difference between accuracy? We discussed this. I think we didn't do this.
No, sir. We didn't do the same.
Okay. So accuracy and precision is what we have to discuss today, right? What is the difference between accuracy and what is precision, right? So first I'll be giving the definition. So it refers to the closeness of a measurement, to the true value of the physical quantity. And precision is, what is precision? It refers to the resolution or the limit to which the quantity is measured. First, you write it down. Quickly write it down as fast as you can, because I have to discuss few more topics today. Written, everyone? Good.
So 1 minute, sir. Just one.
Yeah, no problem. Take your time, but do it fast. See, I will not ask you to memorize physics. I will never ask you to memorize physics. I'll try to give you the explanation of each and everything that is happening there. But the thing is that you need to revise. Otherwise, that is difficult for yourself. Because these 2 years are very crucial, and that is not like class 9th or 10th that you have passed. That was very easy. Here, the thing is like little bit different. You have to work really hard if you want to get something in class 12th, and then apart from that, in the competitive exams, be it JEE, NEET, CUET, whatever it be. So you have to get detailed concepts, and only concepts will not do. Revisions plus practice, that is also required.
So completed, sir.
Good. Now see here, I am giving you two values. I measured, I had a cloth. Okay, this is a, like, let us say this is a stick. Okay, and its measurement is 3.59 meters exactly. I had two of my students, A and B. Let us say Kaushik and Lata were two of my students, and I asked them to measure the same stick. Okay, asked them to measure the same stick. What Kaushik did, he measured the stick and he got a value 2.89754, and Lata measured the same stick. She got a value 3. Let us say 5. Can you tell me by reading the definition who is accurate and who is precise? Be louder, be louder, be louder.
So the value of P is accurate, sir, and the value for A is precise.
Exactly. And this is precise. In physical quantity, we want both precision and accuracy. Okay. A is accurate because its value was more close to the like true value. And A is precise because the length, the resolution it took, whatever length he measured, there may be some error due to, like, errors can be due to anything. It can be due to his error also, personal error also. It can be due to the error of the instrument also. It can be due to the error of the surrounding also. Anything can happen. But the thing is that he tried to be precise. He took the resolution limit detailed. Okay, the resolution was very detailed. You all like to click photos, isn't it? So you must be going with the higher resolution cameras now, because they used to capture the details of the picture or scenario, whatever you are taking. So that is the resolution, and that is precision. Understood, everyone? Yes or no?
Yes, sir.
Good. So this is accuracy and this is precision. Right, then we'll be studying about the next topic that is quite interesting: errors in measurement. Errors in measurement. Okay. So what is error? The error in measurement. Error in measurement is equal to the difference in true value and measured value. True value and measured value. Okay, error is the measurement. Error in measurement is equal to the difference between true value and measured value. Whatever you have, error is the difference, that is the gap between the true value and measurement. Okay, this is a very easy definition. Then types of error. Types of errors. There are different types of error. It is not only that you have made the mistake. Mistakes are due to many things. One is constant error. Constant error. Second one, systematic error. And the third one, random error. Systematic errors are of different types. First of all is instrument error. Instrument error. Second one is imperfection. Imperfection in experimental technique. Can you read this? The blue words that I'm writing there, blue sentences. Is it readable? No. Okay. Okay, then I'll be writing this errors in different page. Types of systematic errors in different page. So written till here, shall I change the page? Small definitions also you can write here. Affect each observation by same amount. That will happen constantly. You cannot eliminate it. Random error. Occurs irregularly. Okay, that is random. And random and is random in magnitude and direction. It can happen anywhere. Any magnitude, any direction, it can happen. Systematic error, I'll define in the next page. Write it down fastly. See, this chapter has got lots of theories, but from the next chapter, it will be quite interesting. Motion in one dimension, motion 2 dimensions, force, work, energy, power. So those are quite interesting, but these errors, dimensions, and vernier calipers, measurements, all these things we have to apply in all the chapters of class 11th and 12th. That will be helpful there. That's why we study this chapter initially. Done till here, everyone?
Sir, can you repeat the lines you wrote in blue for a constant error, sir?
Constant error I've written after that. Affect each observation by same amount. Affect each observation by same amount.
Okay, sir.
Sorry. Affect each observation by same amount. In random error, I've written occurs irregularly and is random in magnitude and direction. For example, if you have a broken scale, okay, so whoever takes the measurement from that scale will get the same error. So that is a kind of constant error. In random error, I can give you an example like if person A is taking a reading. If person A is taking a reading, he can like make different errors. It may be due to his attentiveness. Okay, whatever it be. So he can make different errors. Person B will make different errors. So that is random error. That is the reading taken by the observer. That is a kind of random error. Defect in the instrument is constant error, because whoever take the reading will get the same amount of error. Done? Shall I change the page?
Yes, sir.
Okay. Now systematic error. What is systematic error? Systematic error is they occur in a particular direction. They occur in a particular direction. Either positive or negative. And there are following types. First one is personal error. Personal error. Due to individual. Second one is instrumental error. Instrumental error. Due to inbuilt defect in instruments. And the third one, imperfections in experimental technique. You are taking the reading incorrectly. Okay. And the last one is errors due to external cause. Errors due to external cause. Okay. There are some external causes also. For example, attentiveness of person. Second thing, like if the temperature has increased, the length of steel tape will also increase, because steel corresponds to temperature. Do you know that? Steel responds to temperature. It expands on heating and cools on like cooling, contracts on cooling. So due to that also some errors can come. So that is inevitable. You cannot control the temperature unless and until you can do the experiment in the lab where you can control it. So these errors are there. Written, everyone? Tell me when it's done.
Few minutes, sir. Someone to wait.
Done?
Then, sir.
Okay. So now we'll be discussing about some errors. Okay, how we work upon the elimination of error. How can we get the rid of the errors, and how can we, like if we have, for example, if we have taken a reading, okay, and A1, A2, A3, A4, such times, any times reading we have taken for a particular thing. If you want to measure a particular quantity and we have taken n times reading of that, n students have come and taken the same reading and they have given the values A1 to AN. Okay, so what we'll do, we'll check the mean value. What is the mean value? Okay, what is the mean value? So how we calculate the mean? Mean is sum of all the observation by number of observation. This is the mean. Okay. For example, if somebody has taken, okay, I'll give the examples at the end. So mean is what? Mean is sum of all the observations by number of observations, right? Next thing is that first one that we have to do, we have to calculate absolute error. You understand it right now, and then I'll give you the definitions. Absolute error. So what is absolute error? Absolute error is the magnitude of mean minus the exact error. So that is denoted by delta A. Absolute error is denoted by delta A. Mean error is denoted by A bar. So if you want to calculate absolute error, delta A1 will be what? That is the error in the first measurement taken from the mean. We assume that mean is the correct value. We assume that the mean is the correct value. So first one, what the difference is there in the first observation and the mean? That is the absolute error. So it is A bar minus A1. Similarly, A2, what is the absolute error in the second observation? That is A bar minus A2. For example, if I've taken 3 readings, 1, 2, and okay, I asked 3 students to take a reading, and they give me the reading as one took the reading as 1 meter, second took the reading as 1.5 meter, third one took the reading as 0.5 meters. Okay, so these were the 3 readings. What will be the mean? Mean will be 1 plus 1.5 plus 0.5 divided by 3. Divided by 3. So that will be 3 upon 3, that is 1. So that is the mean value. And we will assume that this is correct unless and until we don't know the exact value. For example, for a particular quantity, we don't know the exact value. So what we'll do, we'll take the n number of observations, how many times we can take, and that to be divided by n so that we can get the mean value. And we will assume that mean value is correct. Now, how do we calculate the absolute error? The absolute error in the first measurement, that is 1 minus 1. That is, sorry, first I'll write this. A bar minus A1. So that is 1 minus 1, that is 0. That means no error is there in the first measurement, absolute error. What is the absolute error in the second measurement? So that is 1 minus 1.5. So that is 0.5. 0.5 is the error. Minus 0.5 is the error in the second measurement. Third measurement, what is the absolute error? So this is 1 minus 0.5. So that is plus 0.5 in the third measurement. Okay, so these are the 3 absolute errors. I'll give you the definitions in the next class. First, you understand till here. Then we'll calculate the mean absolute error. Mean absolute error. What is mean absolute error? So we'll calculate the absolute error in all the measurements and we'll take the mean of it. So delta A bar will be what? Delta A1 plus delta A2 plus delta A3. Okay, one more thing. Mod of this. We don't want the negative sign. We will just take the positive sign. N times divided by n. So we got delta A1 0, delta A2 minus 0.5, delta A3 plus 0.5. So let us calculate the mean absolute error. Mean absolute error will be 0 plus mod of minus 0.5 plus mod of 0.5 divided by 3 observations we have taken, delta A bar. So what will that give? You know the mod? Do you have any confusion in mod? Do you have any doubt in mod? What is mod? Tell me, do you know that or not?
Sir, if it is a negative value distribution.
Yeah, then you know this. Good. So even if we have a negative value inside, we'll get the positive. So this will be 1 divided by 3. So our mean absolute error is 1 by 3. Okay. Next term, what we have here is the relative error. Relative error. Relative error. What is the relative error? So relative error is mean absolute error divided by the mean value. What is my mean absolute error? That is 1 by 3. What is my mean value? See in the last page. Mean value. What was the mean value? 1. So 1 by 3 divided by 1. That is 1 by 3 only. So that is my relative error. Okay. Now what is my one more thing is that percentage error. Percentage error. This is the last term. So that is relative error into 100. That means delta A bar minus A bar divided by A bar into 100. So that is delta A bar by A bar is 1 by 3 here into 100. That means 33.5. 33%. This is my percentage error in this particular observation. So there are 4 or 5 terms. One is mean. Mean is the sum of all observations by number of observations. Absolute error is mean value minus each observation. Mean absolute error, the mean of all the absolute errors. And at last we have relative error. Relative error is mean absolute error by mean value. And if you multiply that 100, we get percentage error. Did you understood this 4 points? Yes or no? Everyone?
Yes, sir. Understood. Understood.
Any doubt you have here? Boys side, I could not hear that. Did you understand this? First row students? Good. Last row? Middle, all of you? So if you'll not understand it right now, it will be difficult for you. Come with revision in the next class. I'll ask the definition of each of them. Okay. Come with revision in the next class. Two more classes are required to end this chapter. At the end, we'll be solving questions, and I want you all to come with the learned formulas so that I do not require to write the formulas there while asking the questions. So try to practice the questions of the subjects of the topics that we have done already. You can ask me the doubts n number of times until and unless you get it clarified. Don't scare, don't feel shame of it, don't feel your question is stupid. Yeah, go on.
Forgiveness, can you please move on to the previous slide, sir? We didn't write it.
Okay. Done, everyone?
Yes, sir. Completely, sir.
Everyone, shall I stop sharing?
Yes, sir. Okay, sir.
Okay.
Thank you, sir.
Okay, then come with revision in the next class. Otherwise, you'll get the punishment. Right? I just required to give 2 hours or 1.5 hours daily to physics. Okay, then. Bye, everyone. Hope you like the session.